a function is analytic within a circle can be expanded by Taylor series. A function is not analytic within a circle, we can expand by Laurent's series, right? A function is not analytic in a particular point, we are applying Laurent's series. So how to variate Taylor series and Laurent series? Simply, in a Taylor series only we get the positive power of the expansion of the function f of z. But in Laurent's series, you may get positive power as well as a negative power of this, the corresponding term z minus a. Like this you may get. This is the main difference. In negative powers, the function is not analytic. So that's why we are saying we can expand the function f of z at a point. That point is not analytic, right? So this is the formula, but we are going to expand Laurent series by using binomial expansion. Most of the case we are going to apply binomial expansion. By using that expansion we are going to find Laurent's series. So please read the example. Expand f of z 1 by z plus 1 into z plus 3 in Laurent series valid for. So here in this problem 3 different circle is given, region is given, right? So in a different region we are going to find different expansion, right, is most important, right? So solution. So given that 1 by z plus 1 into z plus 3. So by using partial fraction, try to write a sum of 2 unique fraction, right? If you use partial fraction, you may get, you can rewrite this term as a by z plus 1 plus b by z plus 3. So if you want to find a, you may use this expression z plus 3. You can substitute z equal to minus 1. Z equal to minus 1. So from that you may get a equal to 1 by 2, b equal to 1 by z plus 1. You have to substitute z by minus 3. So you may get z equal to minus 1 by 2. Now try to substitute a and b in the expression. So from that you may write f of z as, I am going to take 1 by 2 as a common term because a and b both are same, right? So 1 by 2, 1 by z plus 1 minus 1 by z plus 3. I am going to take, this is equation 1. So first one is, I am going to take the region 1 less than modulus z less than 3, right? So here if you draw this region here, so I am going to draw a circle of radius 1 and of radius 3 of same center, right? From that you may get this kind of region. So the z value should lies between 1 to 3. That means this is the annulus region. Annulus region you may get. So you have to take z, any z in this region. This is the meaning. So the radius of smaller circle is 1 the radius of larger one is 3, right? So with the help of this region, I am going to take like this, 1 minus 1 less than modulus z and modulus z less than 3. So from that I am going to rewrite this term as less than 1 modulus z divided by 3 less than 1. So simply you can rewrite this term as 1 by z modulus 1 by z less than 1. Here also you can rewrite z by 3 less than 1. So that means, suppose if you take any point inside this region, that value, that means they are corresponding 1 by z. 1 by z is also less than 1. So suppose if you take z equal to 2, so what is 1 by 2? It is also less than 1. Similarly, suppose if you take z equal to 2.5, what is 2.5 divided by 3? That value is also less than 1. Why we are finding this inequality? Because now I am going to apply binomial expansion. So in this part, if we want to apply that binomial expansion, that means I am going to apply this formula 1 plus x minus 1. If you want to apply this formula, modulus x should be less than 1. So for this case, I have defined this inequality here, right? So now I am going to use equation 1. What is equation 1? So f of z equal to 1 by 2. So try to make z plus 1 should be 1 by z. So how to write this term coming like 1 by z. So if you take z as a common term, definitely 1 by z is coming inside the closed bracket. So for that, so depending upon this inequality, if we want to use this inequality here, I want to make 1 by z is coming inside the closed bracket. So for that, I am going to take 1 by z should be a constant common term in this expression in the denominator, right? So if you take 1 by z as a common term, you may get 1 plus 1 by z. Similarly, in the second factor, I am going to take z as a common term again. If you take 3 as a common term, because the 3 lies in the denominator, right? So for that I am going to take 3 as a common term in the z plus 3. You may get z by 3 plus 1, right? So now I am going to rewrite 1 by z. I am going to shift this term to numerator. So 1 by 1 plus 1 by z whole power minus 1 minus 1 by z 1 by 3 1 plus z by 3 whole power minus 1, right? Now I am going to rewrite this term as 1 by 2z 1 plus 1 by z whole power minus 1 minus 1 by 6 1 by 1 plus z by 3 whole power minus 1. Now I am going to apply this binomial expansion because 1 by z modulus 1 by z less than 1 z modulus z by 3 is less than 1. So now I am going to apply that expansion. So from that you may get 1 minus 1 by z plus 1 by z whole square and so on minus 1 by 6 1 minus z by 3 plus z by 3 whole square and so on. So this is the expansion in the region 1 less than modulus z less than 3, right? So next one, next region modulus z greater than 3, greater than 3. That means if you draw the circle of center 0 comma 0 radius 3, so outside this region we want to take z, that z should lies outside this circle, right? So if you want to, by using this expression modulus z less than 3, you can rewrite 3 less than modulus z. That means 3 by z modulus less than 1. 3 by z less than 1. But the given function have two factors. One is z plus 3, another one is z plus 1. So for that, by using this inequality, you can expand z plus 3. So what about z plus 1? How to expand by using this expression? My question. So how to expand z plus 1 by using this expression is most important. So that means, suppose if you take z is outside the circle, their corresponding value. So what is the value of z? It may be more than 3, right? If you take 3.5, if you take 3.5, what is the value of 3 by 3.5? That value should be less than 1. Similarly, by using this idea, suppose if you take z should be 3.7 or 3.8 like this, what is 1 by 3.7? That value is also less than 1. So for this, trivially you can take, because we want to expand z plus 1 also. So for that, by using this inequality, you can take, without loss of generality, you can take 1 by z is also less than 1. 1 by z modulus 1 by z less than 1, right? So now I am going to apply this inequality, these two inequality in a equation 1, right? In equation 1, f of z equal to 1 by 2 1 by z plus 1 minus 1 by z plus 3. So I want to make z should be comes in the denominator. So for that, in the second term I am going to take z as a common term, right? So by using this inequality, I am going to take z as a common term in this inequality, in this factor. Then only you can apply these two inequality here, right? So now you may write 1 by 2 If you take, directly I am going to write, if you take z as a common term, you may get 1 plus 1 by z whole power minus 1. The second term you may get minus 1 by 2 z 1 plus 3 by z whole power minus 1. Now by using binomial expansion, because 1 by z, 3 by z both are less than 1. So if you apply that expansion, you may get 1 minus 1 by z plus 1 by z whole square minus and so on, minus 1 by 2z into 1 minus 3 by z plus 3 by z whole square minus and so on. So here no need to expand, simplify this expression. The question is expansion. Expand the given unique function in terms of some other function. So they are asking. So no need to simplify. That means you have to multiply, and simplification is not, no need to expand. Right? Simply it's enough to expand this term like this. Right? So next one. Next region is what is the next region? Zero modulus z plus 1 less than 2. Less than 2. Right? So simply you can take the simple expression. Better for your understanding, I am going to take u as z plus 1. U as z plus 1. So in previous case, the region contain only modulus z. The second region, also modulus z is coming. Right? But the third region, modulus z plus 1 is coming. So for that I am going to take z plus 1 as u. It is very easy to apply. So that's why I am going to take modulus, that means z plus 1 as u. So from that you may get modulus u less than 2. Modulus z less than 2. It is very easy to take. So from that you can use modulus u by 2 less than 1. So by using the diagram, it is very easy to draw the diagram. With respect to u, if you draw this diagram, I am going to draw the region with respect to u. I am taking u as another complex number, that's all. If you draw this circle, you may get suppose if you take u should be inside the region. Suppose if you take u as inside the region, what is u by 2? It's also lies inside the region modulus z, modulus u less than 2. Here 0 is not included, most important. Right? So now what is equation 1? Equation 1 is f of z 1 by 2 into 1 by z plus 1 minus 1 by 2 into 1 by z plus 3. So only now I am going to substitute, I am going to use this assumption. I am going to convert from z to u. So from that you may get 1 by 2 into u minus 1 by 2. If you want to expand, simply you can substitute. So from that you may get 1 by u plus 2. U plus 2. So here only u is coming. If u is coming means no need to expand this term. Only it's enough to expand this term only. So no need to expand 1 by u. Right? So for that I am going to apply this inequality here. If you want to apply this inequality, you have to make you have to write s in terms of u by 2 coming here. If you want to write u by 2 is coming better, you have to take 2 as a common term in this factor. So 1 by 2u minus, if you take 2 as a common term, you may get 1 by 4, 1 by 1 plus u by 2. So next one is so 1 by 2u minus 1 by 4, 1 by u by 2 whole power minus 1. Definitely you can apply binomial expansion. So 1 by 2u minus 1 by 4, 1 minus u by 2 plus u by 2 whole square minus and so on. So now you can replace u by z plus 1 here. So from that you may get f of z equal to 1 by 2 into z plus 1 minus 1 by 4, 1 minus z plus 1 divided by 2 plus z plus 1 divided by 2 whole square minus and so on. So this is the expansion of f of z in the region 0 less than modulus z plus 1 less than 2, right? So in this region, instead of z plus 1 or z minus 1 like this coming means you have to substitute the another variable. So from that you can get the expansion of the particular region, right? So next one, last one is modulus z less than 1. Modulus z less than 1. So it is nothing but, suppose if you draw the region, you may get, if you take z should be the corresponding region. So from that you may get, suppose if you take any value inside the region z, that value should lies less than 1. But in this problem it contains two factors, one is z plus 1, another one is z plus 3. So by using this inequality you can expand z plus 1, right? So another factor is z plus 3. So here with the help of this inequality try to find out the inequality of expansion of z plus 3. So simply you can rewrite z by 3 is also less than 1. Is it right or not? Because we are taking z inside the unit circle, that should be less than 1. Again if you divide that z should divided by 3, that value is also less than 1. So are you agree? So z less than 1, z modulus z is less than 1, then modulus z by 3 is also less than 1. So you can apply, you can directly without loss of generality you can take these two inequality. By using this inequality you can expand the function f of z, right? So last one, so therefore I am going to expand f of z equal to 1 by 2 1 by z plus 1 minus 1 by 2 1 by z plus 3. I am going to rewrite 1 plus z whole power minus 1. I am going to take 3 as a common term in the second factor. So 1 by 6 1 by z by 3 whole power minus 1, which is equal to 1 by 2 1 minus z plus z square minus and so on, minus 1 by 6 into 1 minus z by 3 plus z by 3 whole square minus and so on. So this is the answer. Right? So next one. Next one is second problem. Expand f of z equal to 7z minus 2 divided by z power 3 minus z power 2 minus 2z minus 2z in the region 1 less than modulus z plus 1 less than 3, z plus 1 less than 3. Alright. So before using this region, try to write this function as a sum of unique factor. That means try to apply partial fraction here. So now I am going to rewrite. So it is nothing but, you can factorize the denominator first. Factorize the denominator. So from that you may get f of z. F of z equal to 7z minus 2. If you take z as a common term, you may get z square minus z minus 2. You can use factorization minus 2. You can write minus 2 as 1 2 so that means 1 into minus 2. If you multiply 1 into minus 2, you may get minus 2. If you add, you may get minus 1. So from that you can rewrite this term as z plus 1 z minus 2. Right? Now you can rewrite a by z plus b by z plus 1 plus c by z minus 2. So here these three factors are distinct. So you can apply Heaviside method. By using Heaviside method, it is very easy to identify A, B, C. Right? So what is Heaviside method? If the factors are different, you can apply A by all the terms except z. Right? Because we are going to find A value. The denominator of A is z. So except z, you have to write all the terms. For what values the z is going to be 0. Only 0. So you have to substitute z equal to 0 in the remaining expression. So 7 z minus 2 z plus 1 z minus 2. If you substitute z equal to 0, you may get 1. You may get 1. Similarly, you can find b equal to 7z minus 2 z into z minus 2. If you substitute z equal to minus 1, if you substitute z equal to minus 1, you may get minus 9 divided by minus I think plus 3. If you divide, you may get minus 3. Minus 3. Right? C is 7z minus 2 z plus 1 into z. You have to substitute z by 2. You may get, the answer is, I think, 2. So from that you can write f of z as 1 by z minus 3 by z plus 1 plus 2 by z minus 2. You can take, this is equation 1. This is equation 1. Now I am going to take the region. I am going to take the region. The region is 1 less than modulus z plus 1 less than 3. By using like a previous problem, here I am going to take u equal to z plus 1. U equal to z plus 1. So from that, this term is reduced to 1 less than modulus u less than 3. So from that, try to draw the region with respect to u. So from that you may get, this is 1 radius, this is radius 3, complex point. So the region of this inequality is, you may get like this, annulus region. Annulus region. If you take any point u, right, if you want to take any u, that 1 by u is less than 1. Similarly, if you take any u inside the region, u by 3 is also less than 1. So without using this diagram, directly you can take, by using this inequality, you can write as 3, 2 inequality, right? So from this you can identify 1 by u is less than 1. So simple. If you take any value inside this region, that 1 by u it's also less than 1. For binomial expansion purpose, we are finding this inequality. So u by 3 is also less than 1. Now I am going to rewrite from 1. So f of z equal to 1 by z minus 3 by z plus 1 plus 2 by z plus 2. Only we have calculated the inequality in terms of u. So for that, better try to change from z to u. So with the help of this assumption. So instead of z, try to substitute u minus 1. Simple. If you substitute, you may get 1 by u minus 1 minus 3 by u plus 2 by u plus 1, right? U plus 1. Now you can apply these two results. I think it's enough. One inequality is enough to do this, right? I think I did one mistake. So better you can put minus. So I forget to put minus. Minus is coming means you can write u minus 3. U minus 3. You can rewrite z minus 2 as u minus 3. Right? Now I am going to apply this inequality by making this expression as 1 by u. Here I am going to rewrite u by 3 is coming. Like this, I am going to take u as a common term in this factor, 3 as a common term in this denominator. So from that you may get which is equal to, so no need to expand the second term because only u is coming, right? So if you take u as a common term, you may get 1 minus 1 by u minus 3 by u. If you take 3 as a common term, you may get 2 by 3 into, directly I am going to apply 3 into u by 3 minus 1, u by 3 minus 1. So which is equal to 1 by u into 1 by 1 minus 1 by u whole power minus 1, 3 by u. If you take minus as a common term, 2 by 3. After taking minus, you have to shift this term to numerator. So 1 minus u by 3 whole power minus 1. Now you can apply, because 1 by 3 is less than 1, u by 3, modulus u by 3 is also less than 1. You can expand by using binomial expansion. So 1 by u into 1 plus 1 by u plus 1 by u whole square and so on. So you must know the formula. The expansion for 1 minus x whole power minus 1 is 1 plus x square and so on. So I have applied this formula here, right? Minus 3 by u minus 2 by 3, 1 plus u by 3 plus u by 3 whole square and so on. So after expanding, try to substitute u by z plus 1. So therefore, f of z equal to 1 by z plus 1, 1 plus 1 by z plus 1 plus 1 by z plus 1 whole square and so on, minus 3 by z plus 1 minus 2 by 3, 1 plus z plus 1 divided by 3, z plus 1 divided by 3 whole square and so on. So hence the expansion of this problem. Thank you.